This is Digitalker
and Jameco JE520.
Welcome. Previously, I've done speech synthesizer projects based on the General Instruments SP0256 and on the Votrax SC01A. This week, I'm going to do one on the Digitalker. I've already got my board here. I'm going to go through the design of it and talk about some of the unique things about this chip. And near the end of the video, I'm going to go through all of the available ROM images that I have managed to get my hands on and play the speech from all of them so that you can hear what the Digitalker chipset is capable of producing. Now, one of the Digitalker chipset sellers I encountered was George out in the Netherlands, and George was kind enough to send me not only the SSR1 and SSR2 images for the Digitalker chipset, but also the National Semiconductor datasheets and application notes. So let's start by taking a look at the datasheet for the chip, and then we'll figure out how we can interface it. So the Digitalker is a speech synthesis system. It's actually multiple chips. You need both the Digitalker IC itself as well as the speech ROMs to go with it. And it is based on digitized speech. So the Digitalker differs from speech synthesizers like the SP0256 or the Votrax SC01. Those ones you build words by stringing together basic building blocks of speech called phonemes. With the Digitalker, each word is digitized in its entirety, and it is digitized and encoded using a custom algorithm developed by Forrest Moser. And this algorithm, it compresses the speech down so it can be fit on a ROM. So one of the natural consequences of this is that you have a very limited set of vocabulary. You can only say the words that exist in the ROM itself. So here's a picture of how the speech synthesizer would typically be used. You've got 8 bits of input go in to select the word. That gives you 256 possible words. Now, it's usually not the case that the ROM includes 256 words because the ROM is just not that big. So usually there seems to be about 100 to 150 or so. But anyway, you select your word with those 8 digital inputs, and then you pulse a write bit, and that will tell it to speak that particular word. After it's done speaking the word, it generates an interrupt, and that interrupt will tell your microcontroller that you can load the next word. Speech comes out from a digital pin and goes into a filtering system and an amplifier. So let's see, I think here's a picture of the filter circuit. You've got an op amp, an RC filter, audio decoupling capacitor, and then you go into some kind of an amplifier. Simple enough to interface. You can actually interface this chip without even using a microprocessor. You could just connect switches to it and make it speak words all by itself. Just kind of neat, and if you look through application notes, there will actually be a few applications where people have done something like a ROM chip that stores several words in sequence to be able to make it speak sentences, and sequenced via TTL logic so that you can make something talk without actually having a microprocessor. Maybe that was important back in the day when microprocessors were more expensive and microcontrollers were fairly not uncommon. Now, as I said, the vocabulary is limited to what it comes with the various national semiconductor ROMs. Now, the chipset would typically include the SSR1 and SSR2 ROMs, which would include this list of words. So you've got a lot of digits, you've got letters, some tones, and then some common words. Now, there was also an SSR5 and SSR6 ROM that included an expanded word set. You would add this to the basic one, and then you could say these additional words. So for example, the SSR5 and 6 had useful things like abort or forward or incorrect or intruder. You could imagine making a alarm system out of this, intruder or smoke, room. Lots of useful stuff in here. Unfortunately, I do not have a copy of the SSR5 and 6 ROMs. I've kind of looked around, I can't find them. I assume somebody has them someplace, but these things become hard to find. If you do have the SSR5 and 6 ROM images, I would love it if someone would share one with me so that I could complete my set, but I will probably keep looking for them. Now, Jonathan Gavarihu is one person I found on the net who is quite helpful and has several ROM images, and he was kind enough to share them with me. So here is a list of all of the ROMs that are in my personal possession. Now, just because I have these ROM images does not mean I can necessarily distribute these. They were given to me by Jonathan, and I told him it was for my personal use. It was not for giving out to others on the internet. If I was to redistribute them, I would probably have to clear it through him, and then he may in turn have to recursively clear it through other people who may have given him some of the images. We don't want to take anything that anyone went to a bunch of effort to get these decoded out of some piece of equipment and give it away without their permission. And there's also a concern that the companies that produce these devices might have active copyright claims and might consider this their valued intellectual property. So maybe going back to the original companies and asking them would be nice before dumping these images on the internet. I'll have to think about it. I'll have to ask around a little bit, but this is what I have managed to come across, and these are the things that I know currently exist because, I actually have them. So first off, we have the SSR1 and SSR2 ROMs out of the National Instrument Digitalker kit. Those ones are described in the datasheet. SSR5 and SSR6 are also described in the datasheet, but I don't have them. I would very much like to get my hands on them. I assume somebody someplace has them because they did exist, but I don't know who would. JE520 was a kit sold by Jameco Electronics, and there were a total of 4 ROMs from it. Genesis is an alarm panel, has various words like burglar and intruder and various alarm sensor related words. It's a talking alarm panel of some sort. Sensaphone and also a duophone were devices sold for monitoring either a home or a business, and you could call into this thing over the phone. It would tell you the temperature and it would let you listen to the room, stuff like that. So kind of a talking home monitoring thing. The duophone variant was sold by Radio Shack. I'm assuming the Sensaphone. I'm not sure who sold that. And then Scorpion is, I think it's a pinball or arcade game. Now, at the tail end of this video, I will actually play these from the Digitalker so you can hear what these things sounded like in their various devices. Okay, let's walk through this schematic one section at a time. Starting up here at the upper left, I have a boost converter. And the reason for this is because the Digitalker chipset requires more than 5 volt. If you watch my previous video on my Votrax project, then you'll notice I did the same sort of thing there, where it was more convenient to run the board off of a single 5 volt supply than both a higher and a lower voltage supply, so I used a boost converter. This 3-pin header is for a Pololu boost converter that converts 5 volts on up to 9 volts. I built in some footprints for some fuses because, especially with my vintage projects, I like to be very cautious about something going wrong and damaging the vintage IC, so there are fuses on both the 5 volt and 12 volt supplies. There are also TVS diodes that would catch any screw-ups or power surges. Next, down here, we have the microcontroller. I used an Atmega AT328, something that I've been using in a lot of my projects. It's just a good microcontroller, easy to program, with a lot of digital IOs. I've got a couple headers for it here. This header is for in-circuit programming, so that we can program it without having to pull the chip. And this here is an I2C header that I can use to connect this board to some of my other projects. Typically, I would do that with like one of my Raspberry Pi projects, for example. Next up, we have a couple of other options for controlling the speech synthesizer. Down here, I put an ESP8266, a header for an ESP01 board. ESP8266 is a great little Wi-Fi chipset, and it can be interfaced over transmit and receive lines, so you can talk to it over serial very simply. I also included a small 3.3 volt power supply for the ESP8266 since it is a 3.3 volt device. Now, up here we have the third potential way to control this, which is to control it via a good old 25-pin or 9-pin serial connector. So just like the olden days, if you were to have something like a Votrax Type and Talk or something like that, it would have a big old 25-pin serial connector. Also here is a 6-pin header that fits a popular FTDI breakout cable. So you could use any of the number of widely available FTDI USB to serial cables and plug it in here and be able to plug this into your modern computer that way. Next, let's talk about the speech synthesizer. So here we have the Digitalker chip. And I've wired it up to the microcontroller in sort of the obvious way, which is the 8 data bits that select the word go into 8 lines in the microcontroller. We also have coming out here a chip select, and then we have a write pin, which connects to the microcontroller. We have a CMS. There's an interrupt pin, which is how the Digitalker lets the microcontroller know that it's ready for a new word. There's a pin here where the digital speech comes out, and it'll run into this filter section that we'll describe in a moment. And then there is over here where the Digitalker interfaces to an external memory IC. So the Digitalker does not store the speech internally. You always have to have this external ROM. And like most ROMs, it's interfaced via a set of address lines and a set of data lines. In this case, I chose to use a 39SF040, which can store 512 kilobytes of data. Typical Digitalker chipset is like 16K, so you could represent many sets of words in this. And as you can see, I broke out the extra pins, total of 4 of them broken out, with paths to connect them to the microcontroller. Now let's talk about this filtering and amplification section. So the speech comes out here, and then the datasheet calls for it to go through an op-amp. So I used an LM358N, powered by the same 9-volt supply as the Digitalker. And then we get to this little bit of oddness here, which is filtering on the output. Now the datasheet calls for a simple resistor capacitor filter. Potentiometer, I found this on one of the schematics when I was looking up other people's designs. I found this on a page called AFOX Consulting and Design, and the author of that project chose to put a potentiometer here. Now maybe he was thinking that he could make the output filter tunable. I'm not really sure. I should probably ask him why he did it, but it seemed like it couldn't hurt, so I did the same thing. Rather than using a fixed resistor there, I put in a potentiometer. So we come out of the op-amp, we go through a resistor and capacitor. That is our filter. This here is a 0 ohm resistor, and then we go into this pot, which is our volume control. Now you notice there's some components here marked no populate there and there, a 0 ohm resistor here, no populate resistor there. So the reason for all of these no populate and wired across components is just that I have tried to use a similar filtering circuit in several of my speech projects and left lots of blank footprints in so that a guy could experiment around with it, because different data sheets call for different things. But for doing it the Digitalker way, you pretty much go through the op-amp, through the filter, into the volume control, out through this audio decoupling capacitor, and then we go into an amplifier. Now I chose, just like I did with my Votrax board, I chose to use a TPA 2016. That is a module you can get at Adafruit, and it is controllable via I2C. So the nice thing about that is that we could leave these potentiometers here fixed, and we could do volume control in software. And that could be really nice when controlling this board from a computer, having a software volume control. Here is a quick look at the PC board. So up here we have the Pololu boost converter, 5 volt to 9 volt with a couple of capacitors, a couple of fuses, and some TVS diodes. We have the Atmega AT328 microcontroller. We have the Max 202 level converter, as well as the DB25 serial port. I believe right here is the header for the FTDI cable if you wanted to use that instead. I've got the ICSP port for the Atmega, and I've got the I2C here for it. If you want to use the ESP8266, you would plug in right there. We have the Digitalker ICs. Here's the big Digitalker IC. Here's the 39SF040 external ROM. Speech comes out, goes into the op-amp, and into the Adafruit TPA 2016 amplifier. And then I have it going into this rather small speaker. So as you can see, pretty straightforward board. Okay, now it's time for a quick demo. I have the board hooked up to a Raspberry Pi. You can see I've got 4 wires connecting it. This would be plus 5 volt ground, the SDA and SCL, so it's hooked up via the I2C bus, and then it will be emitting sound on its little speaker here. So I've written myself a Python program that can talk to my board over I2C or serial or the ESP8266. Let's take a look at this vocab.py file. So in this file, I listed the entire vocabulary of all of the ROMs I have. It's indexed by ROM number as well as word number. So for example, the word were came from ROM bank number 3, and it was word 123. If we go and find something like supervisory, I know that came from the alarm panel. Supervisory was bank number 5, word number 79. The phrase "this is Digitalker," that is from the SSR1 ROM, and it's bank 0 and word number 0. So I can tell my tool to just say these words. I called my tool DigiControl, and I'll tell it to say this is Digitalker, then insert 160 millisecond pause, and then say and Jameco JE520. So that will use two different ROMs, the National Semiconductor SSR 1 and 2, and then the JE520, because the word Jameco is in there. So let me go ahead and push this.
This is Digitalker and Jameco JE520.
So let's try a couple more words. Let's do like intruder, burglar.
Intruder, burglar.
That was out of the Genesis alarm panel. And some of these, you'll notice they're actual phrases. So like the sensophone, word number 81 was the entire phrase, warning message received by telephone number. So let me say that entire phrase. Let's see what it sounds like.
Warning message received by telephone number.
Okay, so that's kind of how the program I wrote to do this works. So I can certainly easily interface this to a Raspberry Pi, as I've done here. I could put it in my Hero Junior robot rebuild if I wanted to. I think I kind of like the Votrax better for that project, but this is an option. Well, I hope you've enjoyed this video and this exploration of the Digitalker speech synthesizer. Always wanted one of these back in the day. I'd see it in the electronics catalogs, which is something I never managed to get. Fortunately, eBay, together with some very helpful hobbyists, have allowed me to own one in 2021. I am going to come up with a project for this, and I'll probably do a second video. I'm thinking hooking up some displays and encoder to it so I could be able to flip through the words and make it say various words. Maybe build myself a homemade speak and spell for my daughter. I think that would be a cool project. If you have any good project ideas, something I could build, please let me know and I will try to build it. So finally, for the remainder of this video, just because I have these ROMs with all of these words, I'm going to tell the speech synthesizer to say every word that I have in the vocabulary.
This is Digitalker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 40, 50, 60, 70, 80, 90, 100, 1,000, million, 0, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, again, ampere, and, at, cancel, case, sent. Send, check, comma, control, danger, degree, dollar, down, equal, error, feet, flow, fuel, gallon, go, gram, rate, greater, have, high, higher, hour, in, inches, is, it, kilo, left, less, lesser, limit, low, lower, mark, meter, mile, milli, minus, minute, near, number, of, off, on, out, over, parenthesis, percent, please, plus, point, pound, pulses, rate, ready, right, second, set, space, speed, start, stop, then, time, try, up, volt, wait, Jameco, space, attention, thank you, number, dollar, percent, open, close, time, plus, or, minus, point, divide, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, line, continue, less, equal, great, help, at, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 40, 50, 60, 70, 80, 90, after, again, all, and, away, back, bar, in, before, between, black, blue, break, brown, by, cancel, caution, sent, change, check, clear, command, complete, condition, control, correct, cost, cross, cursor, cyan, dark, data, day, decrease, delete, device, did, disk, display, don't, door, down, drive, end, enter, error, escape, exit, fail, fast, fire, first, forward, from, fuel, function, get, go, good, goodbye, green, gray, have, hello, here, high, hit, hour, 100, if, in, increase, insert, is, it, joystick, key, last, left, level, right, limit, listen, load, low, magenta, million, minute, miss, more, move, my, next, no, normal, now, o'clock, of, off, okay, on, orange, other, out, over, phone, place, play, please, press, program, range, read, ready, record, read, repeat, reverse, right, room, run, save, second, select, send, set, shift, should, sign, slow, speed, spell, start, stop, system, tape, target, test, then, that, the, then, there, this, thousand, total, try, turn, type, up, use, violet, voice, wait, was, where, welcome, what, white, will, with, word, yellow, yes, your, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 40, 50, 60, 70, 80, 90, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Access, alarm, alert, all, and, area, armed, attention, attic, back, basement, bath, battery, bed, bell, box, building, burglar, button, call, case, caution, change, check, child, circuit, close, code, cold, computer, condition, conference, control, current, customer, day, delay, den, department, detector, dining, disarm, display, door, down, east, emergency, entry, equipment, exit, exterior, failure, family, fan, feature, fire, first, floor, from, front, function, garage, gas, glass, gun, hallway, help, high, hold, hour, house, in, instant, interior, intruder, is, key, keypad, kitchen, large, left, level, right, living, lobby, lock, lounge, main, master, memory, night, north, not, number, off, on, open, or, out, over, pan, panic, pass, personnel, secure, security, select, sensor, service, ship, show, side, sky, smoke, south, spare, stare, storage, store, supervisory, switch, system, temperature, test, third, tone, trouble, up, utility, waiting, warning, water, where, west, window, wing, work, zone, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 40, 50, 60, 70, 80, 90, 100. O, AM, PM. Again. Attention. Hello. This is sensophone unit. The time is, the temperature is, degrees. The electricity is, sound level, alert condition, battery condition. Listen to the sound level for 15 seconds. Have a good day. Indicate you have received warning message by dialing within 30 seconds. On, off, high, low, okay, clear, enter, entry error, no number, number limit, high temperature, low temperature, limit. This is telephone number. Please leave a message. Replace batteries. Exists. Alert conditions. Warning message received by telephone number. This is sensophone. System test. Okay. Again. All. Attention. Button. Circuit. Complete. Error. R. Fifth. First. Forward. 4. Fuel. Go. Rate. Greater. Is. Lesser. Level. Low. Next. Of. On. Please. Press. Right. Second. Start. Thank. Third. Try. U. Zone. S.
Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.